Hey guys, this is Shabar here, and today we are going to start with a new series on my video, which is a video series about must-have tools for ham radio, for the modern ham radio, right? So today we are going to go over some basics of NanoVNA and how to go about using it, or like where it's helpful, right? So to give you some background, right, like to demonstrate this, um, I had purchased this cheap Chinese radio, ATX20 Plus, which is a uh, shortwave radio plus AM radio plus FM radio. Along with this radio, right, like got this antenna, which is a telescopic antenna, which has this BNC connector, and you can expand it this way, right? But the funny thing is that this radio is mainly intended for shortwave listening. If you look at it, right, like it's intended for AM, medium wave, and shortwave listening, right? And this antenna is pretty much useless for all those bands, right? And nano VNA is going to help us see why that is so, right? And let's see how we can do that, right? So this is the nano VNA unit which I purchased from Amazon. This costs around $60. You get this attachment with it, which is an SMA cable. And I bought this BNC male to SMA male connector from AliExpress. This is a SMA female to female connector, which also came along with the same kit, right? So using these two, we are going to connect the SMA female wire with our telescopic antenna. So let's go about doing that. Okay, so we have our antenna hooked up all, right? Now let's get started with the nano VNA. If you look at this, for the nano VNA which I purchased, right, like they gave this kind of an lanyard cable with a guitar pick, which is basically used as a touchscreen pick, right? So let me switch on the nano VNA here. Okay guys, so let me switch on the nano VNA for you. So on switching on the nano VNA, as you can see, there are all these colorful traces showing up, right? So you can see there are these three color traces: yellow, magenta, and blue, and there is a Smith chart at the back, right? So in this particular case, we are only going to enable trace 0, and we are going to use the trace 0 to measure the SWR of the antenna, right? So for doing that, let me go here. Let me go to display. Let me go to trace. Let me disable all the other traces. Just double click on them. Right, so now only trace 0 is selected. Let me go back. Now for selecting SWR, what we need to do is we need to go to the format menu. So let me click here again. Let me go to the format menu. And in the format menu, if you see over here, this is the SWR option. So let me click on that. So let me go back. So now that's all we had to do. Now it's selected for. So one more thing which we'll need to adjust over here is, if you see the frequency range over here, the default frequency range is 50 kilohertz to 900 megahertz over here, right? Like, which is a very big frequency range. And the way nano VNA works is it only picks 101 points in the frequency range which is specified, right? So for a higher resolution, we should pick a frequency range where we expect to see the SWR, right? Like, so in this particular case, considering this antenna height, I'm going to pick the frequency range from 80 megahertz to 300 megahertz. So let me do that. So for doing that, click on this, go to the stimulus option over here, click on stimulus, select the start frequency as 80 megahertz, and we're going to put the stop frequency as 300 megahertz. Right, so now if you see, it is spanning from 80 megahertz to 300 megahertz. Right, so we are done with the setup over here. right? Now let me just connect the antenna. Hey guys, so as you can see, I've extended the entire antenna here, right? And if you can see on the screen, it is showing you the SWR curve. I did one more update here. I changed the scale from 1 to 5 here for SWR so that we can see it fully. Typically people keep it like 1 to 3, right? So let me just see where this lower point is right now, right? That is the maximum, or you can say like the lowest SWR. So the point of least reflection, you can say. So around 117 megahertz is where it is situated, which is like around the FM or the higher end of the FM range, right? Now what we are going to see is that as I shorten the antenna, can you show this telescopic antenna here, right? As I shorten the antenna, we are going to see how this thing is going to move, which is going to reflect like what we learn in physics, right? Like the shorter the antenna, the larger the frequency at which it will be resonant to. Okay? So let me reduce the antenna length now. So we'll go like step by step. So I'll reduce like one length over here. So now if you see, the frequency has moved to around 120, around 128 or so, right? So around that point, 128 megahertz, right? Now let me bring it down further, right? So now if you see, it has again moved to the right, right? So let me bring down the marker. Yeah, so now the marker is around like 139 megahertz, right? So let me bring it further down. So if you see now, the thing has moved even further to the right. So now the valley is at 152, around 152 megahertz, right? Let me bring it further down. So from 152 now it has come to 165, close to 165, 168, right? Right. And let me make it even shorter now. So right. So now if you see the antenna depth, right, it has gone to 181, around 181, 185 levels, all right? And I think if I go to the least one now, if you see, when it is fully stepped down, it comes to be around 200-ish megahertz, right? Hey, so we saw that as we change the length of the antenna, the frequency of the lowest SWR, which is, you can say, the resonant frequency, right? That is going all the way from when fully extended around 110 megahertz to when it is fully collapsed, it is around 220-ish megahertz, right? So looking at that, right, like this antenna is pretty much not applicable for use in shortwave, which was expected, right? But this gives a good idea on like how changing the antenna is changing the resonant frequency. And in my view, if I'm using FM, I should always have the antenna fully extended, because that's going to be the best configuration in most scenarios. So that's it from my end. I personally think that's a very valuable tool to have in the ham radio toolkit. We'll continue in the same series further along with other set of tools. Till then, have a nice day. Thank you.